So what is FLEXnCONFU project? In a nutshell, the aim of the project is to demonstrate power to X to power solution that could be easily integrated in a power plant to untap the potential flexibility of the power plant. And the aim is to demonstrate up to TRL7 an innovative, economical, viable, and replicable power to X solution, in which the aim is to produce, starting from the excess of electricity produced by the gas turbine, to produce carbon-free fuel. So we will demonstrate two different solutions. A power to hydrogen solution and a power to ammonia solution at two different TRL levels that I will show you later. But in general, the aim is to produce, starting from the excess of electricity, these two possible carbon-free fuel and reuse them in the combustion chamber, so to inject the fuel in the power plant to decrease the environmental impact of the plant. And of course, the integration of an energy storage. So we will have or the hydrogen storage or the ammonia storage, depend on the solution. Of course, they will help to increase the efficiency of the combined cycle, because we are aiming to enhancing the load leveling via the energy storage. The project started in April, so we are in the very first phase of the project, and it ran for 4 years. So we will reach the end of the project in March 2024. There are involved 21 partners from the GT manufacturing side, from the energy utilities, and for all the value chain related to the hydrogen and ammonia, together with research institutes, etc. And the aim is firstly to start some tests on the combustion of hydrogen and ammonia, and then to have in 2022 both the pilot site related to the power to ammonia and the demo site related to the power to hydrogen ready, and with the power to X solution installed and integrated in the plant to have 1 year of monitoring of our solution. So which are the drivers of the project? The driver could be summarized in 4 main aspects. The first one is related that the natural gas is currently the backbone of the European energy system, and Europe is not yet independent, so there is a lot of interest to decrease the use of the natural gas. So in this aim, we can demonstrate a cleaner solution that could be coupled to fossil fuel power plants. The second driver is related to the hydrogen, which is one of the clean energy vectors that Europe is promoting more and more in the last years. So the use of hydrogen in fossil fuel power plants could accelerate the transition towards a decarbonized society and decarbonized energy system. The third driver is related to the promotion of alternative gases or alternative non-conventional fuel to reduce the gas emission of the gas turbine. And that's why we are aiming to demonstrate the potential of hydrogen, which could be mainly in the short term, and the ammonia that could be have an impact more in the long term as alternative fuels instead of natural gas. And last driver is related to the aim to increase the flexibility and promote the penetration of renewable energy sources. So making the power plant more flexible could help to have a more stable grid to increase the penetration of non-dispatchable energy sources into the grid. Also considering the integration of energy storage in the power plant. So the main goal is to demonstrate up to TL7 so in a real operative plant the integration of power tweaks to power system that could be, from one side, increase the flexibility of the plant, and for the other side, reduce the emission of the power plants, and promoting an integration of power tweaks solution in the power plant. The power tweak system will be installed in a real operative plant in a combined cycle that is working in Portugal and managed by EDP near Lisbon. So the pillars of the project could be summarized in four main pillars. The first one is the use of non-conventional fuels in gas turbine, and several tests will be performed at Cardiff University, both related to the hydrogen combustion and the ammonia combustion. The second pillar is related to the integration of power tweak system real power plant, in which an electrolyzer will be connected to the plant for the production of hydrogen, as such hydrogen will be or directly stored and then burned in the gas turbine, or in the power to ammonia system will be transformed in ammonia before its combustion. The third pillar is related to the development of grid-oriented control strategies, because, of course, the power tweak system should be properly controlled, considering which are the needs and the constraints of the energy markets, or in an optimal way. So we have on board Mass Europe, which is one of the big company in Europe for what concerns the control of power plant, that will closely work with other research institutes such as CIRSE that will proper develop grid-oriented control strategies, and of course that will be installed in both pilot site and demo site. And the fourth pillar is related to, as I said before, to the promotion of the hydrogen and ammonia towards a cleaner energy society. Demonstration of the project will be at 4 different levels. So we will have several combustion tests in a representative industrial scale gas turbine in Cardiff University. Then we will have the demonstration in SAVONA pilot site with the collaboration of the University of Genova, in which the power to ammonia system will be demonstrated at TRL6, integrating a small electrolyzer and ammonia synthesis reactor with an existing microgas turbine that will be properly modified to burn ammonia. Then we will have the full demonstration at TRL7 in RIBATEJO power plant in Lisbon, managed by EDPP, in which we are going to install 1 megawatt electrolyzer for the production of hydrogen, and the hydrogen will be then directly injected in the combustion chamber. But we have already engaged several virtual demonstration sites. One is Tirreno Power, which is a combined cycle in Savona in Italy, and the second one is another combined cycle managed by Engie, in which later on we will demonstrate the potential of FLEXnCONFU solution in such two virtual demo sites. So this is just a slide that will present you the work related to the combustion test rig at Cardiff University, in which several partners are involved to understand both the hydrogen combustion and the ammonia combustion. The focus will be more focused on the ammonia part, aiming at reach 100% of ammonia combustion, and activities at the combustion test rig is led by Cardiff. In the SAVONA laboratory, the idea is to develop a modular and containerized solution and a small-scale ammonia reactor in order to increase the replicability potential of our project and to demonstrate the use of ammonia as an hydrogen carrier. The system will be connected to an existing microgas turbine in the University of Genova laboratory in Savona. Here the main goal is also related to the modification of the existing microgas turbine, so the combustion chamber of the microgas turbine, to burn up to 100% of ammonia. And in this pilot site, we have, together with the University of Genova, there is a Proton Venture and the University of Darmstadt that will work on the ammonia synthesis reactor together with Ichikal that will manage the integration of the whole system. While the complete system of power to hydrogen will be demonstrated in RIBATEJO power plant, which is 400 megawatt combined cycle, in which we are going to install 1 megawatt fast cycle electrolyzer together with a gas compressor and a pressurized hydrogen storage, in which the hydrogen will be produced based on the market needs and the market constraints, so starting from the excess of electricity produced by the plant and accumulated in a storage and reused when it's more convenient. And here we have hydrogenics that will provide the electrolyzer and will work together with Ichikal again for what concerns the hydrogen part and the integration of the whole system. And the plant, as I mentioned before, is managed directly by EDP. And the last part is related to the control strategy. So dynamics model will be developed for both systems, and there will be based on reduced order model, and the aim is to develop the controls that combine predictive capabilities while respecting, of course, which are the constraints of the plant. And the work will be mainly performed by MASI Europe and CIRSE. So, which is the consortium? I already introduced you some of the partners involved. It's a very industrial-driven consortium, and we are going to cover the whole value chain. So, considering energy utilities, gas turbine, OEMs, we have the power plant operator. It's a very huge consortium, which a different partner will cover the different expertise needed for the development of this project. So we have research institute, we have engineering company, we have gas turbine manufacturer, and all the dissemination part is covered by ETN, which is one of the partners of the project. The impact is related to demonstrate and contribute to a more resilient power system via the integration of energy storage. And the final aim is try to load leveling the fossil fuel power generation. And in this way, we are aimed to partially reduce the minimum technical load of the combined cycle and to increase the efficiency of the power plant itself. So in the slide, you could see some numbers that we evaluate during the proposal phase, but of course, all of them should be demonstrated later on in the project, firstly via simulation, and then so starting from the real data of the plant, and then in the demonstration phase that will start in 2023. So this is just a brief overview of the roadmap, so which are the driver and the key exploitable results that are related to the power tweak solution and to the control part. And aim is to reach TL7 at the end of the project and to have already some results ready to be demonstrated to promote on the market quite close after the project ends.